Let's talk about chain discounts. Instead of offering a 25% trade discount, which we could also say as a single discount, in other words, it's one number, 25%. Instead of offering that one number, some manufacturers or some wholesalers offer us a chain discount, let's say 10, 7, 5. 10/7/5. What that means is this. That means we get 10% off the list, then we get an additional 7% off of what was left, then we get an additional 5% off of what was left after that. Now, why would somebody do it that way? Well, it's not just to confuse us. It's not to make us think we're getting a 10 plus 7 plus 5 equals 22% discount, because we're not, and everybody knows we're not. What they do is they use this kind of discounting to make their prices more flexible. In other words, they might say everyone gets this 10% discount, okay, because you're our dealer. And let's say if you order 100 or more in quantity, you get an additional 7% off of what was left. And let's say furthermore, we've been having problems selling this product in Arkansas, so if you're an Arkansas dealer and you order 100 or more, you'll get the 10%, then you'll get 7% off that, then you'll get an additional 5% off that, because we want you to buy more stuff. All right, so we're going to give you more of a discount. That way, they can print their catalogs or put their stuff on their website and just say, here's the list price, and all I have to do is email people a new chain discount page every week or whatever. So it makes their pricing more flexible. Now, let's see how this works. Let's say there were a $400 list, and let's say we got all three of those chain discounts. If you have how many of you have a simple calculator? Okay. Let's do it the simple calculator way, and then I'll show you the other way, which we need to know anyway. Let's take 400 minus 10%. So if we knock 10% off 400, we should get 360. Does that sound right? Now let's knock 7% off of that. And I'm not doing that in my head, so 334.8. Does that sound right to everybody? 334.80. And now let's knock an additional 5% off that. 318.06. Thank you. And if it did not come out even, we would round it to the nearest penny. Okay. Anytime we're doing financial things, you never want to round anything until you write down your final answer. But normally we go to 2 decimal places. All right, so 318.06, that would be our net price. All right, after those 3 discounts. Now, let's look at another way of looking at it. Instead of taking 10% of that, $40, and subtracting it, what could we multiply 400 by to get 960? We could multiply it by 90%, couldn't we? If we're saving 10%, we're spending 90%. So everybody punch in 400 times 90%, or if you have a scientific calculator, 400 times 0.9 equals. Some calculators, they'll let you use the percentage and they'll calculate it immediately. Some you have to press the equals after. Some you need to change it to a decimal. Does everybody get 360 for that? Now let's multiply that. If we're saving 7%, we would be spending 100 minus 7, which is 93%, isn't it? So 400 times 90% times 93%, that ought to give us this number. Does it? All right. And now our last one, if we're saving 5%, how much are we spending? We're spending 95%, aren't we? We're spending 100 minus the savings. So if we say 400 times 90% times 93% times 95%, that should give us this 318.06. Now, these numbers are called the complements of these three discount rates. The complement of 10% is 100 minus 10%, 90%. The complement of 7 is 100 minus 7, 93. The complement of 5% is 100 minus 5%, 95%. Now, what if we bought a bunch of items from this company and they had different list prices? Well, here's a $400 list price. We'd say, okay, that's how much I'm paying for that. If we had a $700 list price, we'd put it here and do the same thing. Well, if we had 30 of these to do, we'd figure out pretty quickly that, you know, when you multiply numbers, it doesn't matter what order you multiply them in, does it? We could figure out what this number is first, and then just multiply it times our list price, and we'd be done. Now, when we do that, we have to use the decimal equivalents. Okay? So, the decimal equivalent of 90%, here's what we do basically when we see a chain discount. We subtract each one of those things from 100% and we express it as a decimal. So 90% as a decimal is what? 0.9, and 93% is 0.93, and 95% is 0.95. So whether you have a simple calculator or a scientific calculator, punch in 0.9 times 0.93 times 0.95 equals. And that'll be a decimal. It'll have a lot of decimal places, and we do not round this thing off. What do we have? Okay. Don't round it.
79515.
79515. Does that sound right? It should end with a 5. 5 times 3 ends with 5 times 9 ends with 5. Okay. Is that what everybody gets? Now, what does that mean? That means that's what we're paying for it. That's the rate we're paying for it. Take this 0.79515, which is still in your display, and multiply it times the list price of 400, and we should get this 318.06. We call this 5-digit number, it's not always 5 digits, but we call the product of the complements of the chain discount amounts, we call this thing the net price equivalent rate. Net price equivalent rate. In other words, that's the same as saying, after all is said and done, we're going to pay about 79.5% for this item. That's our net price rate. Well, what if we wanted to find out how much we're saving? If we're spending 79.5%, how would we find out how much we're saving, rate-wise? Subtract it from 100%, right? In other words, if we're spending 80%, how much are we saving? 100 minus 80. This is not exactly 80%. Notice this is a decimal, though. How do we write 100% as a decimal? 100% as a decimal is just the whole number 1, isn't it? So if we take 1 minus that net price equivalent rate, that'll tell us how much we're saving. So take this number, subtract it from 1, or actually you could just say minus 1 equals, and you'll get the right answer with a minus sign in front of it. Does that look right? What do we call this? We call this the single equivalent discount rate. The single equivalent discount rate. What that means is this. Instead of telling us 10.75 chain discount, they could have said, we'll give you a 20.485% trade discount. They could have said that if all their customers got all 3 of those. Okay? This chain discount is exactly the same as saying a single discount of this much. So they call it the single equivalent discount rate. Now, notice that 10 plus 7 plus 5 is how much? 22. Did we actually save 22%? No. Why not? Ah, yes. Look at the summary page there. Notice in the middle column it says successively lower base. In other words, this 10% was taken off $400, but this 7% was not taken off $400. It was taken off a smaller base. And then this 5% was taken off an even smaller base. All right? Now, again, nobody in the industry is trying to fool anybody else into thinking they're getting a 22% discount. Everybody knows how this works. But just realize, if you're seeing this for the first time, that a 1075 is not the same as a 22% discount. All right? It's the same as this much of a discount. Now, one other interesting fact. Here are the same numbers in a different order. Intuitively, we might think, in other words, when we think of things that have a position, a placeholder, if I say, here are 3 digits, arrange them in any order you want, and I'll give you that many dollars. If you wanted to get the most money, how would you arrange those digits? 743, wouldn't you? If I said, now, I've just given you $743, now arrange them in any order you want, and you're going to have to give me back that much money, how would you arrange them? 347, okay? So you would think, you might think, I thought when I first saw this, that this would be a better discount because you're taking the biggest number off the biggest amount. Seems like this would be a bigger discount than that. But as it turns out, how do we figure these? We take the complements, we subtract each of these percents from 100, express it as a decimal, and you might remember somewhere in your distant past there was a property of multiplication called the commutative property that says you can multiply things in any order you want and you get the same answer. 3 times 4 is the same as 4 times 3. So these 3 numbers multiplied together in any order are going to give us the same answer, which is kind of a surprising fact.